All right, welcome. If you're getting ready for a technical interview, you've probably noticed that questions about Retrieval-Augmented Generation, or RAG, are popping up everywhere. So in this explainer, we're going to get you ready with some clear, confident answers for those tough RAG questions.
So, we're going to walk through 5 key areas that interviewers really like to dig into. We'll start with the most basic question of all. How do you even know if your RAG system is any good?
Okay, let's start with the big picture. An interviewer wants to see that you can take a complex system and break it down into its parts. So that's exactly how we're going to approach evaluating a RAG system. Imagine you're in that interview and they ask, so how do you evaluate the quality of a RAG system? The absolute key here is to immediately break it down. Show them you know that RAG isn't just one monolithic thing. It's actually a two-part system.
And this is the core concept. You have to evaluate retrieval and generation on their own. Think about it. If the final answer is wrong, you need to know why. Is it because you grabbed the wrong information in the first place? That's a retrieval problem. Or did you have the right information, but the model just summarized it poorly? That's a generation problem. You have to separate them to find the real root cause. So that leads us right into our next section. Now that we know we have to check the retrieval step, how do we actually, measure it? How do we put a number on how good it is?
This is a classic follow-up. The interviewer is going to expect you to know the lingo, the standard ranking metrics that everyone in the industry uses to measure how well a system is finding what it's looking for. So first up is precision at K. Just think of it like this. If your system grabs, say, 5 documents, what percentage of those were actually useful? A high precision score means you're giving the model signal, not just a bunch of noise. Then you've got recall at K. This kind of answers the opposite question. Out of all the potentially good documents in your entire database, how many did you actually manage to surface in your top results? High recall means you're not leaving any of those important gems behind. Next is MRR, or mean reciprocal rank. This one's all about speed and efficiency. It doesn't just care if you found a good document, it rewards you for putting the very first correct one as close to the top of the list as possible.
And finally, nDCG. Now, this is definitely the most sophisticated one. It gets that not all relevant documents are equal. It gives more points for the most relevant documents, and it gives even more points when those top-tier documents show up right at the beginning of the results.
So to kind of wrap this up, here's a simple way to think about them. Precision asks, how clean are my results? Recall asks, did I miss anything important? And MRR's all about, how fast did I find what I was looking for? Okay, let's switch gears and tackle one of the scariest failure modes for any AI system, and something interviewers are for sure gonna ask about: hallucinations. Because let's be real, this is what can destroy user trust in a heartbeat. Simply put, a hallucination is when the model just makes stuff up, Instead of sticking to the facts that were provided in the documents it retrieved, it just confidently invents details or states things that are just plain wrong. The most important thing to get across in an interview is that finding these isn't just guesswork. It's a system. You can directly compare the final answer to the source documents. You can use other LLMs to check for faithfulness, and you can even try to trick it by asking questions you know it can't answer. And, of course, you have to check the citations. It's a multi-layered defense. And here's a really great, simple technique. You can actually use one LLM to basically grade another LLM's work. By asking a really direct question like this, you can start to automate a big chunk of your hallucination detection pipeline. It's pretty powerful. Now, when things inevitably go wrong, just looking at the final bad output, it's not enough. To really debug a RAG system, you've got to be able to see inside the black box. You need to see exactly how that output got made, every single step of the way. I love this analogy. It just perfectly captures why these observability platforms are not a nice to have. They are absolutely essential. Without them, you're basically blind, just guessing where on the assembly line the problem happened. A tool like this gives you that total end-to-end visibility. You can see the exact query, the chunks it retrieved, the final prompt it was sent to the model. You can even see things like latency and token costs at every stage. It lets you pinpoint exactly where things broke down. All right, let's bring this all home. We're going to cover the most common problems you'll actually run into when you're in the trenches debugging a RAG system. You can think of this as your go-to debugging checklist. Having this checklist is like having a diagnostic guide for a doctor. When a bad answer comes out, you can just run down the list. Okay, was it a retrieval problem? Is our chunking strategy off? Are we just stuffing way too much context in the prompt and overwhelming the poor model? Or did we just forget to tell it that it's okay to say, I don't know?
And here it is. This is the money line for your interview. Saying this shows you have a really practical, deep understanding of where to look first. It tells the interviewer that you know the problem is usually in the data pipeline before it even gets to the LLM, not with the big model itself. And I'll just leave you with this little puzzle to think about. This is a great scenario because, well, there isn't one single right answer. Being able to argue for either side, or even both, shows a really nuanced understanding of how these two systems interact. It's the kind of thing that shows you're thinking at a senior level. Good luck out there.